Okay, well, thank you for being here, and those of you watching online, thanks for watching online. But yeah, I want to mention or just start bringing to your attention and get you to start thinking about a group project, and and I want you to start forming groups. Okay, so on Canvas or Brew and Learn, there's now a new module for final project information. Right now, I just have a group sign up page. I will add more information. This Friday, I'll talk, I guess, more in detail of what this final group project will look like. But I want you to start forming groups of around 4 people. 4 people, 3 to 4 people. I want to try to avoid groups of 5, but if it's unavoidable, we can have that. But yeah, generally groups of 3 to 4 people, and this will be for your final project. And the final project is going to be a data analysis project. So you will find a data set, and you will apply a lot. My hope is that you'll apply what you've learned in class to this thing, and you'll get a sense of kind of like the start of data science in terms of going out and finding an interesting data set and trying to draw meaning from it. Okay, and so we want to cover that. Okay. So anyway, start thinking about groups. Yeah, I guess maybe on Campus Wire we'll have some kind of thread. Those of you who are in person here, if you want to just kind of look to your left and your right and say, hey, I know you come to class, and we can work together as a group or something. Or on Campus Wire you can say, hey, these are kind of my interests. So one of my requirements regarding the data that you want to use is that at least one person in your group has to be knowledgeable about the data. So that should kind of like without that requirement, the very first time I taught this class, I had a group that chose to look at some wine data set, and nobody in that group knew anything about wine. I mean, some people drank alcohol, but they didn't know what distinguished a good wine from a bad wine or anything like that. And so there wasn't really anything meaningful. Okay. And then they were like, oh yeah, their conclusion was the properties of red wine are different from white wine. And I could have told you that too, right? You can just look at that and you'll know what's a red wine and a white wine. So that's we don't want that. Okay. So if you want to do baseball data, that's fine. That's totally great. But at least one person in your group needs to know stuff about baseball, right? Or if you want to do something related to health, at least one person in the group needs to. So when you start looking for a group and people to work with, you want to kind of talk about okay, these are the things. These are some of the subject areas that I'm familiar with. Okay, but anyway, we'll talk more about that in the future. Today I wanted to go provide more examples of data wrangling using group by and summarize. I know I covered this on Friday, but it's kind of such an important piece of data analysis and stuff that I do want to spend more time on this. I know I think I said in the you should read chapter 5 for combining tables. We'll do that. Okay, we'll do that. But I wanted to do one more lecture on chapter 4 on data wrangling, group by and summarize, and also show how to combine that with ggplot for the data visualization stuff. Okay, so here we're going to revisit this Gapminder data. Okay, so I think last week or a little bit, a few lectures ago, we did some data visualization stuff on this Gapminder, and we kind of did these scatter plots where we looked at GDP and life expectancy, for different countries, and and things like that. Okay, and so this is just kind of what our data set looks like. And starting in 19, it's got estimates. Okay, not these aren't true values, but estimated life expectancy, estimated population, estimated GDP per capita from 1952 to 2007. And it's got a whole bunch of different countries, right? Afghanistan, which is on the continent Asia, Albania, things like that. And I have a total of 1,704 rows. Okay. And the first thing we can do is we can use this function summarize. Okay. And I saw on Campus where there's a good question about what's the difference between summarize and mutate, because they seem similar. Okay. And one key thing to remember is what summarize will do is it's going to just create basically it takes multiple values and shrinks them down to one row, right? When you ask for the mean of a set of numbers, you get one thing back. So summarize is basically just going to create one row, okay? Whereas mutate creates a new column. And so when you use mutate, you're going to get a new column, and you're going to get a value for every single row in that column. But here, summarize just says, okay, we're just going to produce one row, and here the different summary values that I want to calculate is I want to calculate what is the mean life expectancy, what is the standard deviation of life expectancy, what's the minimum life expectancy or the median life expectancy, the third quartile, Q3, 75th percentile for life expectancy, or maximum value for life expectancy, right? And so these are all kind of formulas that we're using here. And here I also have count, how many rows are being summarized, or how many values are being summarized, 1,704. All right, and so for the entire data set, which spans from 1952 to 2007, and for all of the different countries, this is the average. Average 59.5 is the average life expectancy for our entire data set. Now this is a little this is a mean of means, which is a little bit of a weird and wonky thing to do. And that's because the countries are of different size. Okay, so if we said, hey, what's the average, I don't know, SAT score of like freshman admits, right? And you could say, all right, at UCLA, the average SAT score was this, and then you take, I don't know, what's another school, but much smaller. Okay, so there's like Loyola Marymount, not too far away. Okay, they're a much smaller school. Okay, and they have a different average. Do you just take the two numbers, add them up, and divide by 2? Okay, that would be kind of the average of averages. And is that an accurate reflection of everybody, or do you weight the UCLA more heavily because it's a larger population? These are things that you kind of have to think about versus like just averaging, right? Or like, what's the average something in the United States? Okay, do you take all 50 states and just average them? California is much bigger than Wyoming. All right, do you what's the average income in California? What's the average income in Wyoming? And do you just add them and divide by how many you have? Or do you have to say like, okay, California is like 40 billion people. Wyoming, I don't know how many people live in Wyoming. A lot less than that, okay? And do you kind of like weight those averages like that? So here we're just treating every single one of these rows as equivalent, right? We're saying Afghanistan 1952, which is I guess 8 million people, counts just as much as Afghanistan 2007, which has grown to 32 million people, and that counts in Albania in 1952 with around 1.28 to 1.3 million people, counts just as much as terms of like its average. And maybe this isn't the best strategy, but if we're just going to go ahead and treat every single row as the same, this is what happens when you treat every single row the same. Okay. But here we're going to just start off and we're going to say, all right, let's go ahead and just filter to one of the years. So we go to the most recent year, 2007, and let's just look at countries in the Americas. Okay, so Americas being North and South America. All right, so we got Argentina, Bolivia, Brazil, et cetera, for 2007. These are our life expectancy numbers. And I can say, you know what, now I want the average here, okay? And so we can say in 2007, if we just average all of these things, and again, we're treating all of these things with equivalent weight. So Brazil, 72.4, and Bolivia is 65.6. We're just gonna add these numbers up and divide by how many we have. And so we're not saying Brazil gets weighted more heavily and Bolivia gets weighted less heavily. If we wanted to, we could mutate and we could take life expectancy and multiply it by population to get like a weighted number, and then we add all of those up and we divide by the sum of the populations. That's another way to do it, and that would kind of like weight all of these values based on the population. But I'm not going to bother with that, right? I'm going to just take the average of all of these things, or calculate the mean or the median or the first quartile or third quartile, all of these things. Okay. Again, I have na.rm equals true in case there is a missing value. If a missing value shows up, R is gonna complain and say, hey, I can't figure this number out. Okay, unless I ignore anything that's missing. Okay, is this okay so far? This is all just using filter to reduce my data set to begin with, and now I'm applying summarize. And here, again, I just get one row, and here it's saying there were 25 rows that are being summarized into one row here. That's what this count is. Yeah, question?
What does the quantile function mean?
So the quantile is basically for a percentile, but you could put in any number, really. So if you want, so here quantile says I want the quantile prob equals 25 is I want the 25th percentile. So this is a spot where 25% of the values are less, 75% are greater. Here, I want the 75th percentile, right? If you want to figure out like who do I want to allow into my super exclusive club, you can say quantile probability 0.99, and now you'll only get 99th percentile and higher, right? You'll get your top 1%, right? If you want to do like the top 0.1 of 1%, right? You can do probability equals 0.999, and only the top, 1/10 of 1% will be in there. Yeah.
What is the na.rm equals true?
na.rm equals true is ignore any missing values. So the default behavior in R is if I say, hey, I want you to find the average of these things, but one of the values is unknown, R is going to say, I can't find the average because I don't know all of the values. And so you're going to just get a whole bunch of NAs. It's going to say NA because I don't know. NA is for I don't know, or it's missing. And so you have to tell R, you know what? I know I said I want the average of these things, and I know we're missing some values. Just find the average of the ones we do have. And that's what na.rm equals true. It's a tiny bit annoying that we have to do this, okay? But it's also, it will also alert you to, do you have any missing values in the first place, okay? And so we've got that. Okay, so here I did it for 2007. The average life expectancy was 73.6. And then I could say, okay, well, what about 5 years prior? I could plug in 2002, exact same code. The only thing that changed from this slide to this slide is I changed that 2007 to 2002, okay? And, we can see average life expectancy in 2070, 73.6. Average life expectancy in 2002 was a little bit lower, 72.4, okay? And all of these other things, also just shift ever so slightly, okay? 80.7 for the max, 79.8 in 2002. Okay, and you could say, okay, well, should I do this for 1997? Should I do this for 1992? And you could imagine copying and pasting the code and just changing that 2002 to 1997, 1992, 1987, because those are all of the different rows. That would be annoying. So instead, what we're going to do is we're going to tell R to group by year. We're going to say, hey, look at all of these different years. Let me just maximize this and put that over there. Okay, so we're going to say, take all of these years. We got 1952, 1957, all the way up to 2007, and we're going to say group by the years. Now, when we do that, our data doesn't look like it has changed, but it says, you know what, I've got 12 groups, okay? I'm grouping by year, and I've got 12 different groups. From 1952 to 2007, there's a total of 12 different years represented. Okay, and now, so if you look at the code here and the code here, they're very similar. It's pretty much the same lines of code, except I no longer filter by year. I'm still saying I only want the Americas, and I'm going to group by the year. Okay, I'm going to group by the year, and what this will do is it will create a summary row for each year. 2007, a summary row for 2002, right? And so we can see this row, this first row, 2007, 73.6, 60.9, 71.8, right? Average is 73.6, minimum 60.9, Q1 is 71.8. This is the exact same value that I have here. When I said filter to 2007, what's the average? 73.6, the minimum 60.9, Q1 is 71.8, okay? And then this next row for 2002 with an average of 72.4 and 58.1 and 70.7, these are the same values here, 72.4, 58.1, 70.7 for the year 2002, okay? So we can see these are the same values that I would have gotten if I filtered to the year 2007, if I filtered to the year 2002, if I filtered to any of these other years, these are the values that I've gotten, but we don't have to do filter to every year. We can just say group by the years, and then dplyr, part of the tidyverse, handles all of this work and creates the summary values. Okay, so this is a very useful function because you're like, oh, you know what? I want to look at for this grouping and this grouping and this grouping, and it goes through the data this way. Okay, is that okay? And so this is kind of the full table for all 12 of the years that are represented. And so we can see, you know, for all 12 years, we had 25 countries represented, and we can see, okay, yeah, you know, it has steadily climbed from the average in 1952 to be 53.3, gone up to 56, 58, up to 73.6. And we can look at the minimum, the Q1, median, Q3, and maximum values there. Excuse me. Okay, so this is my summary table, and basically a lot of these slides I have the code written here for your reference because I want you to be able to basically do this kind of stuff, but you know, for some other application, some other data set. The code's here, but a lot of times the output doesn't fit on the same slide because the code and so I'll have just the output on the following slide. Okay, and one of the cool things is you can take this summary table, you can save it somewhere, right? So if I wanted to save this, I could put a little assignment arrow in front of Gapminder, save it somewhere. But you can also just take that output table, take this thing, and just pipe it into ggplot and create a plot based off of this. So here, this is what I've done. I started off with the Gapminder data. I said, let's filter to the Americas. Let's group by the year. And let's summarize and just calculate the average, the mean life expectancy. And then after I've done that, I pipe it using % greater than % or Control-Shift-M to insert the pipe. And I pipe that straight into ggplot. Okay. When you do a group by, it's going to create a column for the grouping variable. So here I said group by year, so it's going to create a column for year. Whereas when you just call summarize, you don't have a column for year or something, right? Because here I'm just saying year is equal to 2002, and I called summarize, we don't have a column for year. But over here, when I said group by the year, it adds that column for year, so you know which year we're talking about, okay? So I'm going to take that column year, I'm going to put it onto the x-axis. And then I'm going to take, this column that I created, average expectancy, all right? And I'm going to say, I want my y variable to do that, okay? We're going to connect it using geom line and geom point, okay? And that plots this. Theme line draw just draws the grid lines, and this is the resulting plot. This is a plot of basically this column here, average expectancy. So 1953, 52, it goes from 53.3 up to 73.6 for 2007, and this is what we have. 53.3 up to 76 point something, I forgot. Okay, that's what we have up here. Okay, 2002, it looks like it's right around 75, and or I'm sorry, it looks like it's right around 72.5, 72.4, because this is 2 is 5 years, and so one grid line is 2.5 years, right? So just under 72.5, 72.4 for this one, and so on and so forth. Okay. All right, so this plots. So I've taken basically my summary table, this column for year and average expectancy, and I've created a plot based on that. Okay, and we can kind of expand this to whatever else we want to do. So so what have I done here? I said group by continent, comma, year. What will this do? So I'm putting 2 variables. So I'm taking my Gapminder data, which has 1,704 rows. We've got the different years, 1952, 1957, 1962, so on. And we've got a whole bunch of different countries. We got 5 different continents, right? Africa, Asia, Europe, Americas, Oceanasia, and stuff. So here I'm saying group, and now I'm giving it 2 variables. I'm saying group by continent and year. Okay, and then I just say summarize and calculate the average expectancy. And so what this will do is it says, okay, we are going to take all of Africa 1952, and in our data set we have 52 countries in Africa, and we're going to say 1952, the average of all of the countries in Africa, that average was 39.1. And then we're going to group all of the rows that have Africa 1957. Then we do all of the rows Africa 1962, so on and so forth until we get to Africa 2007. Okay? We do the same for the Americas. Americas 1952, Americas 1957, up to Americas 2007. Same for Asia. Asia 1952, Asia 1957, so on and so forth. And we do that for all 5 of the countries, all 5 continents. Okay? And we can see each of the continents have a different number of countries, right? Africa has 52, Americas has 25, Asia has 33. I don't know how many Europe has. I think Oceania in our data set just has Australia and New Zealand, just 2 countries. There are certainly more countries. There's a bunch of Pacific Island nations that I think would be considered part of Oceania. I don't know. Or maybe part of Asia. It's a little bit murky. How we group countries together, but for whatever reason they're not included in our data set here. Okay, so this is the result of running this code: Gapminder, group by continent and year, and summarize. Okay, so I've done Gapminder, group by continent and year, summarize, and then again I'm going to pipe this summary table, of which I have there's this thing, basically 60 rows of it. We pipe that into ggplot. Oh, I've completely forgotten. I'm sorry. I need to give you view quiz answers. The first 2 view quiz answers today are D and A. D as in dog, A as in apple. D as in dog, A as in apple will be your first 2 view quiz answers. D as in dog, A as in apple. Okay. So we're grouping by continent and year. We've done the summary table, and then I'm basically taking this table and now I'm going to create a ggplot to it. What am I going to do? I'm going to put year on the x-axis. This column for year, we're gonna map to the x-axis. Okay, we're going to take this column, average expectancy, which is what I created using Summarize. We're going to put that on the Y variable. Okay, so we're going to see, okay, how has average life expectancy changed over time? And then, and we're going to differentiate the different continents by using colors. So we're going to say, we're going to take the continent and map it to the color of the line. Okay, and then we say, okay, we want lines, we want points, we want the grid lines. We're going to do theme line draw there. Are we starting to get comfortable being able to read how we're constructing these tables and graphics? That's kind of my hope, that we're comfortable reading this, and then we'll feel comfortable creating these on our own. This is a lot of how we explore kind of big data sets, right? How we start to explore these bigger data sets. Okay, and this is the resulting graphic that we see. Okay, and so we see, across the board, from 1950 to 2007, we see average life expectancy increasing for all of these, for all of the different continents. So Africa goes, life expectancy goes up. Asia, life expectancy going up. America's life expectancy going up, so on and so forth. Okay. Here, what did I do here? I said, let's filter our data set just to the Americas continent. We're going to just, from the Gapminder data, we're going to map year to the x-axis, life expectancy to the y-axis, and we're going to color the points based on the country, points and lines based on country. Add lines, points, draw the grid lines. All right, what does our resulting plot look like? Okay, this is a mess, right? The problem here is I've got 25 countries, okay? And yeah, I can represent all 25 countries with a different color, but it's really hard to tell these colors apart, right? And I say, hey, which line is Trinidad and Tobago? Which line is Puerto Rico? You're gonna look here and you're gonna, I have no idea. Okay, you can't, like, these colors, they are slightly different, okay, but it's, our eyes aren't really good at this. I mean, it's like, okay, we got a rainbow of colors and stuff, and but it's, we can't tell, right? And then I say, okay, what line is this right here, right? This is like, this is an interesting line, this orange one. And you're like, okay, is that Bolivia? Is that Brazil? It's tough to tell, right? What line is this? Okay, this line at the bottom, or what line is this at the top? It's a little bit tough. Maybe some knowledge you might go, okay, you know what? So this one looks like it could be Brazil, Canada, or Chile, and you might know that Canada has the highest life expectancy of countries in the Americas or something like that. So maybe you can tell that one, but again, very difficult to kind of know, right? Is this one Guatemala, Haiti, Honduras? It's a little bit tough, okay? And so without kind of outside knowledge, so the problem is you got 25 colors, hard to kind of distinguish. And so general recommendation: don't have more than 6 or 7 colors in one plot. It's harder to kind of tell, right? You think of how many colors are in the rainbow, right? Red, orange, yellow, green, blue, indigo, violet, Roy G. Biv. And that's 7, and you don't want to push more than that, okay? Once you start going above 7, you run into this problem, and you can't really tell the colors apart, okay? So one possible fix is you just filter the data, all right? So here, the 6 countries in the Americas with the highest population is United States, Brazil, Mexico, Colombia, Argentina, Canada, I think in that order. And okay, yeah, it is, right? And so I filtered based on that, right? I said U.S., Brazil, Mexico, Colombia, Argentina, Canada, and so I've done this filtering, okay? So technically, filtering by continent is redundant right? If I filtered just to these countries, only the Americas will be represented anyway. So I filtered the country, and again, whenever you do, you have a list of countries and you want to limit it to that list of countries, you use percent in percent. Don't use the double equals. Double equals is used for a single value only. Okay? If you have like kind of a list of values that you want to kind of filter down to, percent in percent. Okay? So here, now I have 6 countries represented, and now these colors are easily distinguishable. Okay? So you can see, okay, this one's Brazil, this one's Colombia, that one is Argentina, that one's Mexico, that one is the US, and that one's Canada, right? So you can look at these colors are distinguishable. Okay, so here's your plot, and you can see, you know what? Mexico has made significant progress in terms of life expectancy. Everything, all nations have increased life expectancy, but Mexico had among the lowest life expectancy numbers in the 1950s, and now is number 3 over here, right? It's surpassing, passing Argentina and things like that. So, so that that's a neat find to see in our data here. Okay, to kind of make it even easier to read, one of the things you can do is you could arrange, so by default it arranges the rainbow colors, right, kind of starting in red on one end and ending in I guess it goes kind of like red, orange through purple and ends kind of with pink in the end. You can arrange these by default, it goes by alphabetical order, and here you can rearrange them by a different order here. Okay, so here what I've done is I said, okay, let's look at the year 2007. Okay, so we're gonna use this ordering, right? So I mean, I could have filtered down to 1950, 1960, whatever, and we could have used this order. But here I'm gonna just say, okay, let's go in the order here, and let's make the top one, the red color, the next one orange, and kind of have the colors matching in that way. And so here I'm gonna create kind of the ordering here. I'm gonna say, let's filter to 2007, let's filter down to these countries, and let's arrange them in descending order of life expectancy. So in 2007, these were the life expectancy numbers for the different countries. And then what I'm going to do here is I'm going to just extract this column, okay, in this order: Canada, US, Mexico, Argentina, Colombia, Brazil, in that order. And so the function that we use to extract that column is called pull. Okay, we pull that column country, right? And so I do basically the same code. Gapminder, let's filter down to these countries. Let's select these 2 columns. Let's arrange them in descending order of life expectancy, and then let's extract that column. And here I use the assignment, and I'm going to take those extracted values and store them in this name called country order, right? And so the country order is basically exactly this: Canada, US, Mexico, Argentina, Colombia, Brazil. And now when I create my plot, okay, I still map year to X, life expectancy to Y, and then the color, as I say, make a factor using the country, and the levels will kind of tell the order in which we want this. And so we say levels will be the country order that I've created back here. So this puts it in the order that we see. So rather than alphabetical order, it puts it in the order that I've specified. And so this is the resulting plot, okay? And this is just a stylistic preference, okay? It's the same information as this, okay? But again, these colors are arranged in alphabetical order, whereas these countries are arranged in the order from greatest to least, okay? In the order that it appears here. And in my opinion, it's a little bit easier to match up the countries and their colors this way, okay? But again, this is an optional thing. It's a preferential thing. But I think it looks nicer this way. Okay, sometimes we want to combine individual kind of rows like along with summary values. Okay, so so here I want to show a plot for the individual countries, and I want to have an additional line that kind of shows the average of all of them. All right, so I actually have two different sources of data for the next plot. Okay, for the next plot I'm going to have two different sources of data. One will be the data source that has the individual countries. All right, so that's going to be like the original Gapminder table that has all of the original countries. Okay, the other source of data will be the summary table that just has the average. Okay, summary table that just has the average. So I first have to create the summary table that just has the average. So here I create that here. I do Gapminders, filter down to the Americas, create the summary where one of the columns that we're doing is going to be the average. And so this table, which is my summary table, just has the year and the average. No individual countries. It's just the average for all of the Americas here. And again, here I'm throwing all 25 countries here, but I have the individual countries shown plus the average line showing here. Okay, so how do I have two sources of data? Okay, so one source of data is Gapminder filtered down to the Americas, and I say, all right, we're going to do ggplot. Okay, where we're going to map the year variable to the x-axis, life expectancy to the y-axis, and then country to the color, right? So that's one mapping. I want to add this black line here to represent the average of all of the countries, okay? And so this, if I used Gapminder, there's no value in that Gapminder table that shows the average, right? So the values for this black line over here have to come from the different table, which is my summary table, America's summary table. So I created that on this previous slide. And so when I add another line, okay, so this geom line is associated with this ggplot that has, uses the Gapminder data. But here I'm saying I want to add another line object, but this time the data is coming not from Gapminder, but coming from the different table, America's summary here. And what am I going to draw? We're going to have year to the x-axis, average expectancy to the y-axis. And to kind of distinguish this line from the others, I'm going to say I want the color of this line to be black, and I want the thickness of this line to be much heavier. I'm doing line width of 2. Is that okay? How I'm bringing in my one plot, I'm showing data from one table, which has all of the individual countries. And again, maybe for readability, I would have just filtered down to 6 countries or 7 countries or something like that. But here I just left all 25 countries in there. But then I want to draw this other line, which is coming from somewhere else. This other line is coming from my summary table that I've generated. And you can do that as long as you, as you're adding the other geometric object, in this case we're adding a line, you specify the data table that is going to contain the data corresponding to this object, the line here. And yeah, you can create. Well, I mean, again, this graphic's a little bit of a mess because we got the 25 countries here. But again, sometimes you want to be able to include not just the individuals, but also combine it with the average. Or maybe you don't want just the average line, but you want to kind of combine it with other things. And so that's something we can do. Yeah.
So data from like 2 different data frames you could combine into the same.
Yeah, absolutely. Yeah, it doesn't have to be, the Gapminder and the average of the Gapminder or something. You could have two completely different data frames and bring them to the same plot. Okay. The issue when you do that is if you are, say, plotting different, like if the values are like very different, okay, then it's going to throw off because it has to put them on the same scale, right? So if one data frame, you got year on the x-axis, and the other data frame, you got some other variable or something, it's not going to work out well, right? But you could have different data frames, and as long as you're kind of like using similar values, similar variables and stuff, you can combine them into one plot. Yeah, absolutely. Okay, and again, these are just some examples that I'm producing here, but as you start working on like your group project and you're starting to create your own plots and you're doing your own exploration of the data and you're creating your own visualizations, the best resource you've got is the internet, right? You're going to go and you're going to say, okay, how do I do something like this, right? You've got this idea, you kind of see like where you can get started, but I want to like adjust it, I want to fine tune it, I want to do this and that, right? Go on the internet, right? There's Stack Exchange. The reference manual is also a great resource, and then that the textbook that we're using, the R Graphics Cookbook, is also a great place to look, right? There's only there's only so much I can cover within a lecture, and so I want to make sure you guys know where to start looking for additional things as you start venturing out on your own in your exploration. Okay, before I forget, let me give you your last view quiz answer, which is the letter B. B as in bear. B as in bear. Okay, I just have a couple last few slides. So almost all of these things we've been using like the mean and the average. You don't have to limit yourself to those kind of functions. So here I'm saying, okay, you know what? I want to use sum. Sum is going to add these things up. So here I can say in 2007, what is the sum of all the population and for the countries represented in the table? And again, this our Gapminder data set is notably missing several countries. Okay, but the sum of all of those countries was around 6 billion, 6.25 billion in this in the data here. Okay, in the year 2007, and we can say, okay, let's look at how the sum of the total population of the entire world has changed over time. And so 1950, the population, the total population of all the countries in the data set was around 2.4 billion, and we can see it has been climbing year over year as we've seen. Okay, and as the data kind of continues, we're going to continue to see population growth, but probably also it's starting to the rate of growth is slowing down. It already is slowing down. Okay, but plotting from 1952 to 2007, it's grown like this. Okay, so almost linear from 1952 to 2007, but yeah, eventually, our rate of growth is slowing down a little bit, not dramatically, not yet, and I don't know if we'll ever see. Well, some countries are seeing population decline, but overall, as in global population is still climbing, and yeah. So anyway, we might want to see how population has changed based on different countries, right? So here, what I'm going to do, I'm doing group by continent and year, right? So back here, I'm just saying group by year. Now we're doing group by continent and year. And so instead of getting 12 rows, we now have 60 rows because we got each year, but for the 5 different continents. And again, we're doing this sum, and then I can say, all right, let's create a line plot. And so you can see all of these different the different kind of continents, and well, so Asia has always, you've got your biggest countries, China and India, or India and China, with the greatest population, so it's great there. But you can see, in 1952, Europe was had more population than the Americas or Africa, and the Americas surpassed Europe in population in around the 1970s, and then Africa surpassed Europe in population, and then Africa has surpassed the Americas in population, total population, over time. Okay, and so this is what we see. Okay, Oceania really only has Australia and New Zealand in this data set, so continually at the bottom there. Okay, we'll go ahead and end here for today, and we will take we'll see you guys on Wednesday.